Good afternoon. Am I audible?
Yes, madam.
Okay. So in last lecture we have started unit number 8, influence line diagrams, and we have started how to draw influence line diagram for simply supported beam, and also we have solved numericals on simply supported beam. So today we will continue cantilever beam. Okay. So please wait. I will share screen. Then we will start cantilever beam. Okay, so today we will see how to draw influence line diagram for cantilever beam. So first we will see standard cases and then we will solve numericals. So please write down draw ILD for cantilever beam. Next is draw ILD for cantilever beam. ILD for cantilever beam. Okay, so cantilever beam means one end is fixed and other end is free. So here one unit load is applied at a distance of x meter and the total span for this beam is L meter. So this is the cantilever beam. Suppose this is A end and this is B end. Now here if fixed end is provided, at that time total 3 reactions will be generated for fixed support. One is vertical reaction, we will call as a RA, horizontal, but here horizontal or inclined force is not there, so we will eliminate. Then what is remaining? Movement, so we will call as a MA. This movement is called as a MA. So this is the cantilever beam. Now here we will apply first equation, that is summation FV, which is equal to 0. So summation FV means we have to take addition of all vertical forces. Here only 2 vertical forces are there. Whenever we will consider or take summation addition of vertical forces, at that time upward forces we will consider positive, downward forces we will consider negative. So this RA going upward, RA, and this 1 unit load is going downward, so -1, which is equal to 0. So therefore RA, which is equal to how much? 1. So this is RA, which is equal to 1. Okay, after that we will calculate movement. Okay, so for finding out movement, second equation you have to apply summation movement at any point which is equal to 0. So we will take movement at a point. So this one creates clockwise or anti-clockwise movement. This 1 unit load clockwise movement. So 1 into perpendicular distance is x. After that this MA anti-clockwise. So minus MA, which is equal to 0. So x, which is equal to MA. So from this you will get the value of MA and the value of MA, which is equal to x. So these are the reactions. After that we have to draw ILD for RA. Next step is you have to draw ILD for RA. Draw ILD for RA. Draw ILD for RA. Okay, so for that You observe here RA which is equal to 1. Okay. And at B end, no load. So ILD for this cantilever beam is only rectangular section. So ILD is rectangular. And here value is 1. Here also 1. And this whole diagram is positive. This is the span L meter. This is span L meter. So this is the ILD for RA. After that, we will draw ILD for MA. ILD for MA or ILD for movement. So second point is ILD for movement. ILD for movement or MA. ILD for MA. So already you know that the value of MA which is equal to X. But you observe here this MA pushes beam to downward. So MA which is equal to minus X. You have to consider here. जर ही एमएचं रोटेशन जर क्लॉकवाईज असतं म्हणजे अपवर्ड बीमला पुश करत असतात तर आपण प्लस एक्स ऍज्यूम केलं असतं पण हियर एमए इज पुशिंग डाउनवर्ड टू बीम दॅट्स व्हाय एमए विच इज इक्वल टू minus x we will put here. Now we will find out at A. We will find out at A x which is equal to 0 distance. बघा A point ला x ची व्हॅल्यू किती पुट करणार आहे आपण 0. So MA which is equal to minus x which is equal to minus 0, that is MA which is equal to 0. After that you have to calculate at B. At B, then you have to calculate at B. At that time x which is equal to how much? X which is equal to L distance. So x which is equal to L we will put here. So MA which is equal to minus x which is equal to minus L. And then we will draw ILD for MA. Okay, so first we will draw baseline. So suppose this is our baseline. Now at A point the value of MA is 0 and at B point the value of MA is minus L. That means this goes below baseline, and after that you have to join by inclined straight line. Why we are connecting by inclined straight line? Because of here you observe x raised to power is 1. If x raised to power is 1, at that time connection is inclined straight line. So this diagram is in negative and the value of this ordinate is L. And this is the span is also L. This span is also L. So this is the ILD for MA. This is the ILD for MA. ILD for MA. ILD for MA. Then we will draw ILD for shear force. Next point is ILD for shear force. This is suppose second point ILD for MA. This is first ILD for RA, and third one is the ILD for shear force. ILD for shear force. Whenever we will draw ILD for shear force, at that time we have to assume distance. First we will consider first case as a x should be less than z, and second condition x should be greater than z. Here we will put z which is equal to 0.7 L. The z ची व्हॅल्यू काहीतरी पुट करायची म्हणून आपण किती पुट करायचं 0.7 L. So first condition is x is less than z. So for this first you have to draw shear force diagram, and according to this diagram you have to locate the or you have to find out the value of shear force for particular case. So we will draw here span for case x is less than z. So suppose this is our cantilever beam. This is original beam. A end is fixed and B end is free. Now we will locate z location, suppose here. Okay, suppose this is C point and here z, or this value is nothing but z. This distance is z. So remaining distance is L minus z. And here suppose at this location our unit load is applied, and this perpendicular distance is x. So this condition is x should be less than z. Now for this figure we have to draw the shear force diagram. Okay. So already you know that the value of MA is here, MA which is equal to X. And here one reaction is there, RA. So RA which is equal to 1. Now we will draw shear force diagram for this particular beam. Suppose we will extend these lines here. Okay. Now, according to our concept, first we will draw here baseline. First we will draw here baseline. Now, whenever we will draw shear force diagram, at that time you have to use some principles. That is, we have to start from left to right. Upward forces we will consider positive, downward forces we will consider negative. So at a point, upward RA will be there. So we will draw here RA. Now suppose this is RA. After that, you observe here in between A to this 1 unit load, there is no any load. So diagram is constant up to this point. After that, here minus or downward 1 load will be there. Okay, so here downward load will be there. Up to this node here only. आता बघा कुठे क्लोज होणार आहे तुमची बिलो बेस लाईन जाईल का तिथपर्यंत बेस पर्यंत ह्या लाईन पर्यंतच येणार आहे. बघा आता आपण इथे किती ड्रॉ केलेली आहे, RA which is equal to 1 आलेले आहे. म्हणजे हा अपवर्ड किती गेलाय तुमचा 1 गेलेला आहे. RA ची व्हॅल्यू 1 आहे ना, इथं 1 ने 1 गेलेला, हा कॉन्स्टंट राहिला. मग आता इथे बिलो 1 येणार आहे, म्हणजे कुठे टच होणार आहे तुमची बेस लाईनला. सो डायग्राम विल टचेस हियर. Okay. Now, after that, this 1 unit load, there is no any force. So, shear force diagram is constant. पुढे काही force diagram येणार आहे का? नाही येणार. So, here value is 1. Now, we have to find out shear force for this particular case. So, how we will find out this? By extending Z location. So, we will extend this Z location. And this touches to baseline here. You observe here. So now you tell me shear force which is equal to how much? Shear force for x which is equal to x is less than 0, z which is equal to 0 kilonewton. Shear force किती असणार आहे तुमचा 0 असणार आहे for first case. Now we will check for second case. Second condition is x is greater than z. Okay, so for this, first we will draw figure and then we will mark shear force value. So first I will draw here original beam. After that you have to draw shear force diagram for that particular beam. Suppose now x location is greater than z. And this is last point. We'll locate here values. So this end is fixed. This is A and this is free end. And our x location now here. Suppose this is 1 unit load and this distance is x. Now we will locate x. Sorry, C here. Suppose C point. That means this distance is z and this remaining distance is L minus z. So for this you have to draw shear force diagram. So here RA force is there which is equal to 1 and here one moment is there MA. When we will draw shear force diagram, at that time this moment we will not consider. So here we will draw shear force diagram for this. So suppose this is baseline. Now at a point 1 unit load is there. So up to this we will draw here. From this A to unit load, there is no any load. So diagram is constant up to this. After that one downward. So here one closes. Now our shear force diagram is over. So we have to extend here Z location. So we will extend Z location here. And accordingly we will calculate the value of shear force. So Z location is here. So now you tell me the shear force which is equal to how much? Here one value is there, here one value is there. Okay. This is A point, this is C point, and this is B point. Okay. So shear force which is equal to shear force which is equal to 1, and after that we have to combine these two figures. For x is less than z, value is 0, and for x is greater than z, value is 1. So we will draw combined shear force, combined ILD for both cases. So now we will draw ILD for shear force. Okay. So first we will draw original beam. Okay. Instead of first we will draw here baseline. For condition 1, up to Z point. For condition 1 up to Z point, shear force is, suppose here our Z location is there. Suppose here A point and here B point. So in between A to C, you observe here, in between A to C, shear force is काय असणार आहे तुमचा 0 असेल आणि C च्या पुढे तुमची shear force व्हॅल्यू किती येणार आहे 1 येणार आहे. So from A to C, no value is there, 0, and after that the value is, or shear force diagram is here like this. One value will be there. So this is the ILD for shear force for cantilever beam, and this end is fixed. So this is 0.7 L. Suppose this total distance is L. From this L minus Z, that is 1 minus 0.7, which is equal to 0.3 L. So this is, and this value is 1. This value is also 1. This is the ILD for shear force at Z. Now we will draw last diagram, ILD for bending moment. 4-point ILD for bending moment at Z, which is equal to 0.7 L. Here also Z, which is equal to 0.7 L. So again here we have to consider two cases. First condition is x is less than z, and second condition is x is greater than z. So for this, first we will draw original figure or original beam. So this is our original beam. In that we have to apply first condition, that is x is less than z. So suppose this is our original A point and this is 1 unit load. This distance is x. Here we have marked z distance. So this distance is z, and this remaining distance is L minus z. This is B point. Okay. Here one vertical reaction will be there, and the value of reaction is 1. And here one moment will be there, MA, which is equal to x. So this is our figure. For x is less than z. Now we will take section at this distance, xx. Section at this z point. So we will consider this beam. We will consider this beam, here xx section, here B point, and this span is L minus z. You observe here from this C point to B, there is no any load. So bending moment is how much? 0. Bending moment is 0. So for x is less than z, bending moment value is 0. Then we will check for second condition, that is x is greater than z. X is greater than z. Second condition, x should be greater than z. X should be greater than z. Again you have to draw here original beam. Now our x location is greater than z. So we will mark here, suppose, and this is A point. This is A point. Then this is 1 unit load. So this is our B point. We will locate here C point, that is this distance is z, and this distance is L minus z. Okay. And this distance is x. This distance is x. Here one vertical reaction is there, RA, which is equal to 1, and one movement will be there, MA, which is equal to X. Now we have to take section. So we will take section here, this XX. Now we will consider this portion because of here only one load will be there. Okay, one load and one movement will be there. So suppose this is our fixed and here XX section. Okay, here one unit load is there, RA which is equal to 1. This distance is Z. Okay. And this MA which is equal to X. Now you tell me movement for this particular case. कशी movement calculate करणार हूँ? Bending moment which is equal to कशी calculate करणार? This RA pushes upward. Okay. So 1 into perpendicular distance is Z and this MA pushes downward. So minus X. So bending moment which is equal to कशा असणार आहे तुमचं हे Z minus X. So bending moment is Z minus X here. Now we will put the value of X here. The value of X here, or we will write summary here. Summary. So if X is less than Z, X is less than Z, that is bending moment which is equal to 0. And if X is greater than Z, X is greater than Z, at that time bending moment which is equal to Z minus X. Now we will put the value of X. We will put the value of X. So X which is equal to Z. We will put X which is equal to Z. At that time bending moment which is equal to Z minus Z which is equal to 0. Now we will put X which is equal to L. X which is equal to L. At that time bending moment which is equal to Z minus L which is equal to, आता Z ची value इथे आपल्याला put करावी लागेल. So the value of Z is 0.7 L minus L. Now you tell me bending moment which is equal to how much? Yes, how much? Minus 0.3 L. So bending moment which is equal to minus 0.3 L. Okay. Then we will draw influence line diagram. For X is less than Z, bending moment is 0. And for X is greater than Z, bending moment is minus 0.3 L. That means our diagram is below baseline or above baseline? Below baseline. So suppose this is baseline. Okay. After that, we will locate points here. So suppose this is A point. So this is our C point. That is, this distance is Z and this distance is L minus Z. Okay, we will write distances above baseline. So here 0.7 L and this distance is 0.3 L. Now from this A to C, bending moment is 0. After that, for second condition, bending moment is minus 0.3 L. That means below baseline, and we have to join at Z location. So this distance is here minus 0.3 L. This is negative figure. So this is the ILD for bending moment at Z which is equal to 0.7 L. Okay, once again we will see from starting. So here also you have to draw ILD for reaction, movement, shear force and bending moment. In simply supported beam, you have to draw ILD for RA as well as RB. But in cantilever beam, this B point is free. That's why here vertical reaction is not there. So movement will be there. So first you have to calculate the value of RA and the value of MA. According to this, you have to draw this influence line diagram for RA. The value of RA which is equal to 1. Here we have put it and draw this ILD for RA. After that, you have to draw ILD for this MA. So the value of MA which is equal to X. But this movement pushes beam to downward. That's why M which is equal to minus X we have assumed here. After that, we have calculated the value of movement at A point. Whenever we will calculate at A, we will put X which is equal to 0. And accordingly, we have calculated the value of MA. at A point. Similar way, you have to find out at B point. Whenever you calculate at B, at that time you have to consider x which is equal to L. So here we have put the value of x which is equal to L. So MA which is equal to minus L, and accordingly we have drawn ILD for MA. After that, next is you have to draw ILD for shear force. Whenever you draw ILD for shear force and bending moment, at that time two possibilities are there. X should be less than Z and X should be greater than Z. That means our unit load should be less than located C point, and second condition is unit load is above or greater than this Z location. So first you have to draw shear force diagram. This is shear force diagram, and accordingly you have to extend this Z location here, and where it touches at that point you will get the value of shear force. So this line touches to this horizontal line, and this horizontal line indicates the value of shear force is 0. That's why for x is less than Z condition, shear force which is equal to 0. After that, we have drawn ILD for x is greater than Z. Same way here, unit load is greater than this Z distance. Okay, this distance is greater than Z distance. So first you have to draw shear force diagram. And after that, you have to extend the location of this Z. Wherever it touches, at that point, you will get the value of shear force. It touches at one value, that's why shear force which is equal to 1. And after that, lastly, we have drawn combined figure for these two conditions. So this is our combined figure. Here, this is 0 and after that 1. Now next, last point is remaining, that is ILD for bending moment. So here you have to apply Z which is equal to 0.7. Here again two conditions are there, x is less than Z and x is greater than Z. So here you have to take section at Z point, and wherever less number of loads or movements, we will consider this span. So in between C to B there is no load or no movement, so bending moment which is equal to 0. For second condition, we have taken section, left side section. So here one reaction and one movement will be there. So this reaction will going upward, that is 1 into perpendicular distance is Z. After that, this MA pushes beam to downward. That means hogging type of nature will be there. That's why minus X. After that, we have put a value here. First, we calculated X. For putting x which is equal to z, at that time bending moment is 0. Then we will put x which is equal to L. At that time bending moment which is equal to is minus 0.3 L. And accordingly we have drawn here for this 0 and after that minus 0.3 L. That means only you have to remember this figure, then this figure, and MA figure and RA figure. And from this, we have to solve numericals. So please write down fast. I will give 5 minutes to writing. Write down fast. If your writing is or shall I show next slide? Yes.
Yes, ma'am.
Okay. If your writing is over, we will solve numericals on this cantilever beam. Yes.
Yes.
Okay. So please write down first example. Draw the ILD for. Write down example. Draw the ILD for. Draw the ILD for. Draw the ILD for cantilever beam. ILD for cantilever beam. ILD for cantilever beam with thread which is equal to 7 meter from A. Thread which is equal to 7 meter from A. So this is the question. Now I will draw figure here. So here cantilever beam is given. In that one end is fixed and this is called as A. This end is fixed end and this B end is free. Suppose span is 12 meter and suppose wherever 1 unit load is applied. So you have to draw ILD for RA, MA, shear force and bending moment. So if fixed end is provided, then here RA will be there and this is moment will be there MA. So first you have to apply summation FV which is equal to 0. That is addition of all vertical forces which is equal to 0. So RA minus 1 which is equal to 0. So accordingly RA which is equal to 1. After that you have to apply second condition summation moment at A which is equal to 0. This 1 kilonewton force creates clockwise movement. So 1 into X. And this MA anti-clockwise. So minus MA which is equal to 0. So MA which is equal to X. Now the value of RA which is equal to 1. So first we will draw ILD for RA. ILD for RA. ILD for RA. Now you observe here. Okay, in previous example, बघा तुम्हाला इथे प्रश्न पडला असेल की मॅडम मी पूर्ण रेक्टँग्युलर कसं काय ड्रॉ केली. पडला का प्रश्न की इथं RA ची व्हॅल्यू तर 1 आहे, B ला तर सपोर्टच नाहीये. तरी पण 1 का व्हॅल्यू पुट केली. तरी पण ही रेक्टँग्युलर फिगर का आली. तर बघा RA which is equal to 1 आहे. जर मी A पॉइंटला फाइंड आउट करायला गेले RA which is equal to 1, तिथं जर मी X which is equal to 0 किंवा X which is equal to L पुट करायचं म्हटलं तर RA ची व्हॅल्यू डिपेंड आहे का X वरती? नाहीये. त्यामुळे तुमची फिगर ही रेक्टँग्युलर येणार आहे. जर RA ची व्हॅल्यू X वरती डिपेंड असली असती तर मात्र तुमचा हा ट्रायंग्युलर किंवा 0 वगैरे व्हॅल्यू आली असती. पण this RA is not depend on X. That's why the ILD for RA is rectangular. Okay. Here same you have to apply. So ILD for RA. The value of RA is not depend on X distance. That is the ILD for RA is directly a rectangular section. Okay. And the value is here 1 and here also 1. This is whole diagram positive. This is A point, this is B point. And from this A to B span is L meter, that is L which is equal to 12 meter. So this is the ILD for RA. After that you have to draw ILD for MA. ILD for MA. So ILD for MA. Next B point, ILD for MA. ILD for MA. So already you know that the value of MA which is equal to X, but this MA pushes downward, that's why minus X. So now this the value of MA is depend on X. That's why we will put at A X which is equal to 0 and at B X which is equal to L. बघा movement मध्ये X चं रिलेशन आहे, त्यामुळे आपण A ला आणि B ला फाइंड आउट करतो. So we will calculate at A. Whenever we will calculate at A, X which is equal to 0. So MA which is equal to minus X which is equal to 0. After that we will calculate at B. At B, at that time X which is equal to L. That is minus L. So MA which is equal to here plus L we will put MA which is equal to minus X, so which is equal to minus L. Okay, so MA which is equal to, now the value of L is given, so MA which is equal to minus 12. So this is the value of MA, and accordingly we have to draw influence line diagram for MA. So first we will draw baseline. So suppose this is baseline. At A point the MA is 0, and at B point MA is minus 12, that means below baseline. Okay, and we have to close this figure. So here value is 12. This diagram is negative, and this value is also 12. So this is called as ILD for MA. Then you have to draw ILD for shear force. Then next is you have to draw ILD for shear force. Okay, ILD for shear force. C part, ILD for shear force. ILD for shear force. Okay, in shear force, two conditions. X should be less than Z at that time. For this condition, shear force which is equal to 0. And if X is greater than Z, at that time shear force which is equal to 1. Shear force which is equal to 1. So we will draw figure here. So suppose this is baseline. So our location, Z location, suppose this is A point, this is B point. Now Z distance is 7 meter from A. म्हणजे A पासून 7 meter ला इथे तुमचा C point असेल, and Z which is equal to 7 meter. This remaining span is how much? 5 meter. हा remaining किती असणार आहे तुमचा 5. So for first 0 value, and from this the value is 1. So shear force diagram is like this. Sorry, ILD diagram for shear force. Okay, so this is the influence line diagram for shear force. This value is 1 and this is positive. So this is the ILD for shear force at Z which is equal to 7 meter from A. Z which is equal to 7 meter from A. And then last point is remaining, that is ILD for which part is remaining? Bending moment. The last ILD for bending moment. ILD for bending moment. Here also two conditions are there. X is less than Z, then bending moment which is equal to 0. And X is greater than Z, then bending moment which is equal to how much? Z minus L. Z minus L. You observe here. Bending moment value is here. Z minus X. Z minus X, that is Z minus L. Okay. So Z minus L. So now we will draw figure here. We will calculate this X, Z. Z distance is 7 meter for this particular condition. Minus L is how much? 12 meter. So bending moment which is equal to minus 5. So minus 5 indicates diagram is below baseline. So first we will draw here baseline. Okay. So this is A point, suppose here. This is A point. Here Z location is there. C point. This is Z which is equal to 7 meter. Z which is equal to 7 meter. And here minus 5 value will be there. And we have to close this. So this is negative. Here minus 5. And this is also 5. This is the ILD for bending moment at Z which is equal to 7 meter from A. 7 meter from A. Let me know after you are writing this over. So we will solve next example.
मॅडम ILD फॉर MA तिथं 12च्या जागी 1 येणार.
12च्या जागी
1
1 कसं काय येणार? हं? 1 कसं काय येईल सांगा? बघा MA ची व्हॅल्यू काय? MA which is equal to -x. आपण x म्हणजेच काय पुट करतोय? L पुट करतोय, बरोबर आहे का? MA which is equal to L ची व्हॅल्यू किती आपली? -12 नाही का? हे बघा प्रिवियस एक्झाम्पल मध्ये बघा लक्षात येईल तुमच्या. बघा इथं व्हॅल्यू किती आहे तुमची? मायनस पॉईंट किती MA ची व्हॅल्यू दाखवायची ना तुम्हाला. हा इथं बघा ही व्हॅल्यू किती आहे तुमची? L आहे ना. L म्हणजे काय असणार आहे? दिलेला स्पॅन, म्हणून आपण इथे 12 लिहिलेला आहे. Let me know after your writing is over. सगळे सब्जेक्ट आहेत. टोटल आता बघा okay, if you are writing is over, Shall I take next example? Yes. Okay. So we will take another one example on cantilever beam. So please write down example. Draw ILD for cantilever beam, ILD for cantilever beam for shear force, for shear force and bending moment at Z which is equal to 4 meter, at Z which is equal to 4 meter, at Z which is equal to 4 meter. Here only you have to draw ILD for shear force and bending moment. So here cantilever beam is given. Total span of this cantilever beam is 10 meter. Okay, this is A point, this is B point, and something where this unit load is applied. This distance is X. So you have to draw ILD for shear force and ILD for bending moment. So first we will draw ILD for shear force at Z which is equal to 4 meter. Z which is equal to 4 meter from A. Here continue from A. From A. 4 meter from A. So already you know that here value RA which is equal to 1 and here MA which is equal to X. So first you have to draw, first you write first condition X should be less than Z. At that time shear force which is equal to 0. And second condition X should be greater than Z. So shear force which is equal to 1 and accordingly you have to draw diagram here. So now Z location, that is from A to C distance is 4 meter and remaining distance is 6 meter. So from this 4 meter shear force value is 1 here. This is the shear force diagram. Here one value plus this is 6 meter and this is the ILD for shear force at Z which is equal to 4 meter from A. Then second point you have to draw ILD for bending moment. ILD for bending moment at Z which is equal to 4 meter from A. 4 meter from A. So for first condition X should be less than Z. At that time bending moment which is equal to 0. And second condition X should be greater than Z. At that time bending moment which is equal to Z minus L. So Z is 4 meter minus total span is 10 meter. So which is equal to minus 6. Then we will draw figure here. Suppose this is baseline. This is minus 6. That is below baseline. Suppose here P point is there. This is A point. This is C point. This is B point. 6 minus this distance is 4 meter and this distance is 6 meter. This is ILD for bending moment at Z which is equal to 4 meter from A. From A. Okay, write down fast. So we will take, I will give 1 to 2 examples for homework. Then we will continue overhanging beam. So please write down fast. Okay, your writing is over.
Yes, madam.
Okay, so please take 2 numericals for homework. Please write down 2 numericals for homework. Draw ILD for ILD for cantilever beam, cantilever beam, cantilever beam at Z which is equal to 8 meter from A, 8 meter from A. So here cantilever beam is given. Total span is 12 meter. Total span is 12 meter. Suppose 1 unit load is applied. Here load is not matter. Only you require this span. Now here draw ILD for cantilever. That means you have to draw ILD for RA, ILD for MA, shear force and bending moment. If particularly mentioned, draw ILD for shear force and bending moment, at that time for shear force and bending moment. If question is not particular, at that time you have to write all. Okay, suppose in examination, question is asked, suppose in ISC, question is asked, draw ILD for cantilever beam at Z which is equal to 8 meter. At that time, first step is your summation FB which is equal to 0. Accordingly, first you have to calculate RA. After that, M. From this RA, you draw ILD for RA. From this movement, you draw ILD for MA. After that, you do calculations for shear force here. X is less than Z and X is greater than Z. Only don't write X is less than Z shear force which is equal to 0. Because of in ISC question will be asked for 8 marks. And जर तुम्ही इथे X is less than Z shear force 0 डायरेक्टली लिहिलं तर 8 मार्क परत द्यायला तुम्हाला प्रॉब्लेम येतो. थोडं कॅल्क्युलेशन लिहा कारण ISC ला मी 8 मार्कला क्वेश्चन टाकणार आहे. म्हणजे हाच आहे असं नाही. एक एक्झाम्पल सांगते तुम्हाला. ठीक आहे. मग हे एस शियर फोर्स 0 कसा आलाय त्याचं तुम्ही थोडं पहिले एक बीम ड्रॉ करा. इथं तुमचं एक्स लोकेशन हा झेड, मग त्याची शियर फोर्स डायग्राम आणि त्याच्यावरून तुमचं काय आलेलं आहे शियर फोर्स विच इज इक्वल टू 0 आणि मग आयएलडी वाटलं तर कंबाईन करून ड्रॉ करा. सेम यू हॅव टू अप्लाय फॉर बेंडिंग मोमेंट आणि त्यानुसार म्हणजे 8 पैकी 8 मार्क द्यायला मला बरं पडेल. नाहीतर तुम्ही डायरेक्ट डायग्राम काढणार म्हणणार मॅडम तुम्ही वर्गात फक्त डायग्राम काढणार तर आम्ही पण काढणार. Okay, so this is first question. After that, you take second question. Alright, done. Second question. Draw ILD. Draw ILD for cantilever beam. ILD for cantilever beam at Z which is equal to 5 meter from A. From A. So here cantilever beam is given. Total span for this cantilever beam is 10 meter. Okay, these two questions. Please sir. आता इथे बघा तुमचे शेप फिक्स आहेत. RA ला रेक्टँग्युलर असणार आहे, MA ला -L असणार आहे इथं. शियर फोर्सला झेड पर्यंत म्हणजे 5 पर्यंत 0 असेल, तिथून पुढे 1 असणार आहे आणि बेंडिंग मोमेंटला काय असणार आहे इथं -5 येणार आहे. हे फिक्स आहे पण त्याची कॅल्क्युलेशन एक्सपेक्ट करा. डायग्राम ड्रॉ करून लिहा कॅल्क्युलेशन. डायग्राम तर ड्रॉ करा. आता x शुड बी लेस दॅन झेड. मग पहिले बीम ड्रॉ करा. तुमचा हा कॅन्टिलीवर बीम आहे, हा एक्स झेड लोकेशन इज हियर. त्याच्यावरून तुमची ही शियर फोर्स डायग्राम अशी आलेली आहे काहीतरी. इथपर्यंत तोडा, इथं नाही आहे ते 0. इथं तुमचा हा झेड एक्सटेंड केला तर इथं व्हॅल्यू 0. Now we will solve examples on overhanging beam. Examples on overhanging beam. So please write down question ILD for or write heading ILD for overhanging beam. ILD for overhanging beam. ILD for overhanging beam. Now you concentrate here. Then I will give time for writing. Okay, so first I will draw here overhanging beam. Suppose this is A point, this is B point, and this is C point. So here simple support provided, here also simple support provided. Okay, so this is A point, this is B point, and this is C. So span for A to B is L meter, and span for B to C is A meter. Span for B to C is A meter. Now we have to draw ILD for this overhanging beam. So overhanging beam means combination of two types of beams. Overhanging at right side, or second possibility is overhanging at left side, and third possibility is overhanging at both sides. Okay. So बघा आता जर आपण राईट साइड साठी डायग्राम ड्रॉ केलं तर लेफ्ट साइड साठी त्याच्या अपोजिट असणार आहे. ठीक आहे. Now first we will extend all lines and then we will draw. First I will extend all these lines. So here you have to draw ILD for RA, ILD for RB, then ILD for shear force and ILD for bending moment. That means total 4 diagrams you have to draw here. ILD for RA and RB म्हटले फक्त का C ला का नाही येणार? फ्री आहे. हा फ्री एंड ला रिएक्शन असते का? नाही. फर्स्ट we will draw ILD for RA. ILD for RA. आता विदाउट कॅल्क्युलेशन मला डायग्राम ड्रॉ करायची आहे. तर कशी ड्रॉ करायला लागेल बघा. फर्स्ट वी हॅव टू ड्रॉ बेस लाईन. आता इथे आपल्याला काय लक्षात ठेवायचं की ज्या पॉइंटला whenever or at which point we are draw influence line diagram, at that point value is 1 unit. According to Muller-Breslau principle, इथे व्हॅल्यू किती आली पाहिजे तुमची 1 युनिट असली पाहिजे. मग आता इथे ए ला किती येणार आहे तुमचं 1 येणार आहे. म्हणजे ऑटोमॅटिक तेव्हा बी ला व्हॅल्यू किती असणार आहे. बी ला 1 कशी असेल, ए ला 1 असेल तेव्हा बी ला किती होणार 0 होणार. ओके, सो यू हॅव टू कनेक्ट लाईक दिस. पण आपलं मुलर-ब्रेसलाव प्रिन्सिपल काय सांगतं की पुढे जो बीम आहे तो रिजिड राहायला पाहिजे. म्हणजे ही डायग्राम काय करायची आपल्याला ऍज इट इज कंटिन्यू करायची. ओके, अँड आफ्टर दॅट यू हॅव टू कनेक्ट. सो दिस इज द ILD फॉर आर. कशी ड्रॉ करायची बघा, परत एकदा सांगते. ज्या पॉइंटला ड्रॉ करतोय तिथं 1 युनिट आलं पाहिजे आणि ऑर्डरला 0. मग ह्या बी पासून सी हा रिजिड पार्ट आहे, तर तो रिजिड ठेवण्यासाठी आपण काय केलं कंटिन्यू काढलं आणि हे जॉईन केलं. सो दिस इज द ILD फॉर आर ए. Now we will write values here. Here value is 1. This is A point. This is B point and this is C. This span is L and this span is A. Now I have to mark this value. कशी काढावी लागेल ही व्हॅल्यू मी कशी काढू बघा. आता इथं we will apply similar triangle rule. L distance ला 1 आहे तर A distance ला किती. So here we have to apply similar triangle rule. So for L distance value is 1. So for A distance value is y. We will assume. So y which is equal to A divided by L. So here value is A by L. हे लक्षात ठेवायचं. तर व्हॅल्यू किती येणार आहे A by L. So this is the ILD for RA. Okay, ILD for RA. ह्याच्यात काही डाऊट आहे का कोणाला. Then we will draw ILD for RB. आता कुठल्या पॉइंटला 1 असेल आणि कुठल्या पॉइंटला 0 असेल कोण सांगतो. कुठल्या पॉइंटला 1 असणार. Now we are going to yes we are going to draw ILD for B. So the 1 value for B. Okay, then 0 value for A. आता हे क्लोज झालं. पण मला तो पुढे B to C पार्ट रिजिड ठेवायचा. म्हणजे काय येणार आहे तुमची डायग्राम ही अशीच कंटिन्यू असणार आहे. बरोबर आहे. इथं करायचं आणि त्यानंतर आपल्याला काय करायचं हा पार्ट जॉईन करायचा. बघा आता ए ला व्हॅल्यू किती आली तुमची 0 आलेली आहे. कारण आपण डायग्राम कुठे ड्रॉ करतोय बी ला. ती व्हॅल्यू असेल तुमची 1. हा स्पॅन किती आहे A to B चा L मीटर आहे आणि B to C चा स्पॅन किती आहे A. मग L ला 1 आहे तर L प्लस A ला काढावं लागणार ना. आता आपण आपल्याला हा ट्रायंगल कन्सिडर करावा लागेल. सो दिस डिस्टन्स इज फॉर L 1 मीटर. For L plus A we will assume y. So y which is equal to L plus A divided by L. L plus A divided by L. मी ह्याच्यातून जर हे सेपरेट केलं तर y which is equal to 1 plus A divided by L. लक्षात आलं का हे कसं लिहिलं बघा. L divided by L plus A divided by L. This gets cancelled. So 1 plus A by L. That means this value is nothing but 1 plus A divided by L. So this is the ILD for RB. ILD for RB. Okay, then we will draw ILD for shear force. Then we will draw ILD for shear force. Anybody having doubt in RA and RB? Okay, once again I will repeat. At which point you are going to draw influence line diagram, at that point this unit rotation or deformation is 1 and another point this is 0. From B to C beam is continuous, so we have to make rigid. For that we have to extend this line and after that you have to close. Now we are going to going for B point. So at B value is 1, at A 0. From B to C we have to make beam is rigid. That's why we have extended this line here and we have calculated this value. Then we will draw ILD for shear force and bending moment. Okay, I will use separate page. Once again I will draw here beam original. So simply supported beam is given first and second is cantilever. Okay, here combination of two beams are there. So this is A point, this is B point, and this is C point. So this distance is L meter and this distance is A meter. Okay. So suppose we will locate Z point here. We will locate Z point here. That is this C, and this distance is nothing but Z, and this total is L. Okay. Now we have to draw shear force, sorry, ILD for shear force and ILD for bending moment. So I will extend all these lines. Now first we will draw for simply supported beam. For simply supported beam, that is first we will draw for A to B. आता सांगा A to B ला ILD कशी असते shear force ची? बघा A पॉइंट पासून Z पर्यंत डाउनवर्ड असते, म्हणजे इथं -Z/L आठवते का बघा, -Z/L. त्याच्यानंतर हे पुढे कंटिन्यू होतं आणि इथं काय येतं तुमचं, हे B ला क्लोज होते. ही झाली सिम्पली सपोर्टेड साठी. But we have to make beam as a rigid. So B to C portion is rigid. So we have to extend this line here. And after that, you have to connect this line. Okay. ज्यावेळी असं combination येतं, first you have to draw diagram for simply supported beams, and after that you have to make rigid. Now we will write values here. So this is A point, A. This is C point. This is B point. We will call as a E here. Okay. Suppose this is E and this is C. Now this distance is A. This distance is Z. This distance is L minus Z. Okay. So here value is minus Z by L, and here value is 1 minus Z by L. Okay, 1 minus Z by L. This is B point, and here value is already we have calculated, that is A by L. So this is the influence line diagram for shear force. आता हे A by L कसं आलं बघा, मगाशी पण काढलं होतं, किंवा आता इथे जर एखाद्याला काढायचं असेल तर L minus Z, L minus Z ला व्हॅल्यू किती आहे तुमची, 1 minus Z, that is L minus Z upon L. So याला आहे L minus Z upon L. तो तुमचं हे A डिस्टन्स आहे. फॉर A सपोज Y, सो Y which is equal to काय येणार आहे तुमचं, हे L minus Z divided by L into A divided by L minus Z. हा A मल्टिप्लिकेशन मध्ये जाईल आणि हा L minus Z डिवाइड मध्ये. So this L minus Z and this L minus Z cancel. So what is remaining? A by L. That's why here written A by L. So this is the ILD for shear force at Z from A, at Z from A. Similarly, we have to draw ILD for bending moment. So first I will draw here baseline. Now first we will draw for A to B, that is for simply supported beam. So for simply supported beam, ILD is up to Z point value is there, from Z to B is close. Okay, and we have to make rigid, that's why it comes below, and we have to close this. So this is the ILD for bending moment. बघा, म्हणजे तुम्हाला फक्त सिम्पली सपोर्टेड आणि कॅन्टिलिव्हरच्या स्टँडर्ड केसेस लक्षात ठेवायच्या, त्या स्टँडर्ड केसेस वरतीच तुमच्या परत डायग्राम्स कनेक्ट होतात. सो दिस इज द A point, this is our B point here, and this is C point. This distance is A distance. Now here E point. This distance is Z. This is L minus Z. And the value of this bending moment is Z in bracket L minus Z divided by L. Z in bracket L minus Z divided by L. Now we have to find out this distance. So we will consider these two triangles and we will apply similar triangle rule. So for L minus Z, distance is how much? For L minus Z, distance is Z L minus Z divided by L. And we have to calculate for this A. So for A, Y. So Y which is equal to Z L minus Z divided by L into this A will at multiplication divided by L minus Z this. So this L minus Z and this L minus Z gets cancelled. So Y which is equal to AZ divided by L. So this value is AZ divided by L. So this is the ILD for bending moment at Z from A. Okay, Z from A. Okay. Just you have to remember ओव्हरहँगिंग कुठल्या साईडला आहे ते तुम्ही नंतर बघा. फर्स्ट यू हॅव टू ड्रॉ ILD फॉर सिम्पली सपोर्टेड बीम and accordingly we have to make rigid. So in that way you have to draw ILD for shear force and bending moment for this overhanging beam. Anybody having any doubt in this? आहे का कोणाला काही doubt? Okay, if no doubt, please write down. So we will solve numericals. Write down this. Write down fast and let me know after you are writing this over. Okay, please write down fast. So we will solve numericals. Or yes, online students, please respond here. Or
Yes, ma'am.
okay. So we will solve numerical. Please write down question. Draw ILD for ILD for draw ILD for overhanging beam, overhanging beam, overhanging beam at at 5 meter, 5 meter from A, from A. So first I will draw here overhanging beam and then we will draw. So here overhanging beam is given likewise. Suppose this is A point, this is B point, this is C point, this distance is 3 meter, this distance is, total distance is 7 meter. So from that you have to locate first Z, and the location of Z is at 5 meter from A. So we will call as a D point this, and this Z which is equal to 5 meter. Okay. So we have to draw now ILD for RA, RB, shear force and bending moment. Now here change is there. In previous example, overhanging at right side. Okay, in previous example, overhanging at right side. But in this example, overhanging at left side. So for this, we have to draw ILD. Okay. First, we will draw ILD for RA. First, we will draw ILD for RA. Okay, first we will draw for RA. So I will draw line here. Now we are drawing ILD for A point. So one value is for A or B. One value is for A or B.
A,
A. And zero value for
B.
P. Okay. So suppose here one value for A and zero for B. So here we have to make rigid for this rigid A to C. So for this B value is 0 and this is A. And after that you have to make rigid. That's why it line continue up to C point. So this is the ILD for RA. बघा प्रिव्हियस केस मध्ये ही आयएलडी कशाची होती आरबी ची होती या केस मध्ये ही आयएलडी कशाची झाली तुमची आरए ची सो हियर we will mark points here. This is C point, this is A, this is the D, and this is B. So this distance is 2 meter, and A to D distance is 5 meter, and this distance is 3 meter. This value is 1. Okay, here value is 1. You have to find out this value. So this value is how much? This value is 1 plus a divided by L. 1 plus a divided by L. So 1 plus a means this 3 meter. 1 plus 3 divided by L, that is span for this AB is 7. So 4 by 7, which is equal to how much? This value is, I will write here, 1 plus 3 by 4, which is equal to, no, 1 plus, then 3 by 4. जर a ची व्हॅल्यू 1 आहे तर c ची व्हॅल्यू 1 पेक्षा जास्त यायला पाहिजे नाही का?
1.75.
No. We have done one mistake here. बघा L ची व्हॅल्यू 3 by 4 आहे का किती येऊ? L ची व्हॅल्यू किती आहे? Span. Wait, I will write here once again. 10 नसतो घ्यायचा तो.
7 आहे की मॅडम.
इथं आपण काय लिहिलेलं आहे? A to B ला L कन्सिडर करतोय आणि B to C ला A कन्सिडर करतोय. मग इथं पण असंच असणार आहे A to B L which is equal to 7 meter and हे A काय असणार आहे तुमचा A which is equal to 3 meter. So 1 plus A divided by L. So A is 3 and L is 7. Now you calculate how much distance? 1 point something.
428.
1428. Okay, so this. इथे लक्षात ठेवायचं A ला जर 1 येते तर त्याच्यापेक्षा जास्त व्हॅल्यू तुमची C ला आली पाहिजे. This is the ILD for RA. Now you have to draw ILD for RB. कशी येणार आहे हो ILD for RB? So first we will draw baseline here. Okay, we will draw baseline here. Now you tell me accordingly. At which point one distance will be there for B. बघा B ला 1 असणार आहे म्हणजे त्यावेळी A ला किती असणार आहे? Suppose this is C point, this is A point and this is B point. बघा आता आपण B point ला ड्रॉ करतो. So 1 for B. B ला 1 असणार आहे म्हणजे A ला किती असणार आहे तुमची 0 असणार आहे. मग A to C पार्ट आपल्याला रिजिड ठेवायचा आहे म्हणून कनेक्शन काय येणार आहे तुमचं कंटिन्युअस असेल. And then you have to draw this. Join this. So this part is D. This distance is 5 meter here. This distance is 2 meter. Here value is 1, and you have to write value here. So this distance is A by L. A by L. So A by L nothing but how much? 3 by 7. So you calculate and tell me which is equal to how much?
0.428.
0.428. So this is the ILD for RB. ILD for RB. Then we will draw ILD for shear force and ILD for bending moment. Okay. So first I will draw here original figure. So here original figure is likewise. Here A bar. This is simply supported. And suppose at 5 meter. So Z point is suppose there. First I will extend these all lines. Suppose here Z location is there. Okay. So now we will draw figure. Here C point, this is C, this is A. Suppose this is a D point and this is B point. His distance is 2 meter and this distance is Z which is equal to 5 meter. Okay. Now first we will draw for which span? A to B. Okay. So I will draw here baseline. Now you tell me. First we have to draw for A to B. A to B मध्ये कशी असणार आहे तुमची डायग्राम? बघा ए पासून स्टार्ट होणारे झेड पर्यंत मायनस झेड बाय एल असेल, बरोबर आहे. तिथून पुढे तुमची काय असणार आहे, तर कंटिन्यू असेल. तिथून ही डायग्राम इथे क्लोज होणार आहे. ही कशासाठी झाली तुमची, ए टू बी साठी. आणि आता आपल्याला काय करायचं, हे रिजिड ठेवायचंय, म्हणजे हे कनेक्शन काय असणार आहे तुमचं, कंटिन्यू असेल. अँड वी हॅव टू जॉईन दिस. लक्षात आले का बघा. फर्स्ट यू हॅव टू ड्रॉ फॉर सिम्पली सपोर्टेड बीम. So suppose this is C point, this is C point, this is A point, this is D point, and this point is B. So here value is minus Z by L, which is equal to 5 by 7, which is equal to how much? Calculate and tell me. 0.71. हे डिस्टन्स किती आहे तुमचं, 2 मीटर. सो डिरेक्टली यू राईट हियर 2 by 7, विच इज इक्वल टू हाऊ मच, 0.29 येत असेल बघा. 285. मग एक तर इथं 0.72 घ्या, जर इथं 0.28 घेणार असेल तर. आणि इथं जर 0.71 घेणार असेल तर इथं 0.29 घ्या. Okay, 0.29. Now we have to calculate this value. This. It is the distance A by L. So this distance is 3 meter. So here A divided by L. So 3 divided by 7, which is equal to 4 to 8. This distance is 3 meter. So this is the ILD for shear force. ILD for shear force at Z, which is equal to 5 meter from A. Then we will draw ILD for bending moment. Okay. So I will draw first baseline here. Okay. Now first we will locate points here. This is A point. Sorry, no, not A. This is C point. This is C point. This is A point. This is A. This is B point, and this is B point. This distance is Z, which is equal to 5 meter, and this remaining distance is 2 meter. So first we have to draw for this simply supported beam. So the ILD for simply supported beam is from A to Z, something value will be there, and from Z to B it will goes at 0. And here value is bending moment value is here Z in bracket L minus Z divided by L, which is equal to, now Z which is equal to 5 meter in bracket 7 minus 5 divided by 7. So you calculate and tell me this value, which is equal to how much? 1.42. Now this is for A to B, but this A to C part is remaining. A to C part is remaining. So you have to make rigid. That's why you have to continue this and join this. So this is the ILD for bending moment, and you have to calculate this value. You have to calculate this value. Suppose we will consider this is similar triangle rule. So for 5 distance, so for 5 meter, this height is 1.42. 1.42. So for this 3 meter, for this 3 meter distance, suppose we will consider y. So y, which is equal to 1.42 into 3 divided by 5, and accordingly you tell me y, which is equal to how much? 0.85. So here distance is 0.85. So this is the ILD for bending moment at Z, which is equal to 5 meter from A. From A. Anybody having doubt? Any doubt in this regard? Okay, please take screenshots. So we will solve next example. And one example I will give for homework. बघा आता इथे काय झालेलं आहे ओव्हरहँगिंग लेफ्ट साइडला आहे तोच जर ओव्हरहँगिंग राईट साइडला असेल तर काय होईल आपण इथे ड्रॉ करूया ठीक आहे प्लीज टेक स्क्रीनशॉट सो वी विल सॉल्व नेक्स्ट एक्झाम्पल इफ यू हॅव टेकन स्क्रीनशॉट shall I take next example
Yes.
okay please later okay so please write down next draw ILD for overhanging beam at z which is equal to z which is equal to 6 meter from A 6 meter from A. So this is the question. First I will draw here overhanging beam. Simultaneously you can also draw. So now overhanging is provided at right side. Okay, that much change is there. So this is A point, this is B point. Suppose this is A point, B point, and this is C. So here this total L which is equal to 12 meter and this distance A which is equal to 4 meter. Now the Z location is at 6 meter. So here we will assume D point and this distance Z which is equal to 6 meter. So for this we have to draw influence line diagram. Okay, please concentrate here. After that you take screenshots. Now you guide me how we will draw ILD for RA, RB, shear force and bending moment. Yes, first we have to draw ILD for RA. कशी ड्रॉ करायला लागेल कुठल्या पॉइंटला किती व्हॅल्यू असेल
Yellow one.
Okay, first we will draw baseline here. Yes. I will mark point here. So you will get idea. So this is A point, this is D point, this is B point, and this is C. So we are drawing ILD for A point. That means one value is at A. One value is at A. Zero value here is at where zero value B. Okay, up to B 0. After that, for B to C, we have to make rigid. So we have to extend this connection up to this point, and after that we have to connect this. Okay, so this is the ILD for RA. Now we will write values here. Suppose this is C point. So this value is 1. Okay, A to D span is 6 meter and D to B span is also 6 meter. That is total 12 meter. This distance is A which is equal to 4 meter. And here this vertical distance is A divided by L which is equal to 4 by 12 which is equal to how much?
0.33.
0.33. So this is the ILD for RA. Now we will draw ILD for RB. Now you guide me. How we will draw this ILD for RB? Okay, first I will draw figure here. Baseline here. Suppose this is baseline. Now at B point value is 1. At B point value is 1. Okay, suppose here. At A point value is 0. So we have to connect up to this. From B to C, we have to be rigid. So it will extend up to this point. And we will close this. So this is the ILD for RB. Then we will write points here. A, this distance is 6 meter. This is the D point. This distance is 6 meter. This is B point and this is C point. Here one value is there and this distance is how much? This distance is 1 plus A by L. So 1 plus 4 by 12 because of A which is equal to 4 meter and L which is equal to 1.33. So this is the ILD for RB. Then we will draw ILD for shear force and bending moment. Then we will draw ILD for shear force and bending moment. So first we will draw original beam. Original beam. So suppose this is original beam here. A to B is simple support provided, and from B to C cantilever support is provided. So we will extend all lines. So this is A to B span first, then this is B to C span, B to C, and you have to locate Z at 6 meters. That is, suppose we will assume here. So this is Z line. Then we will mark all point here. So this is A point, this is B point, this is C point, A which is equal to 4 meter. Okay, so this is D point, this Z which is equal to 6 meter, and this remaining also 6 meter because of total span is 12 meter. Okay, now we have to draw shear force diagram for this particular case. First, we will draw baseline here. Okay, now you tell me how we will draw shear force diagram. From this A point to D point minus Z by L. After that, it will go above baseline, and here Z in bracket L minus Z, and at B point it will close. But from B to C, we have to make rigid. So we will extend this line, and after that we will close this line. So this is the influence line diagram for shear force, and we have to mark values here. So this is A point, this is D point, this is B point, and C. This distance is A which is equal to 4 meter. This distance is 6 meter. This distance is Z which is equal to 6 meter. So here value is minus Z by L, which is equal to minus 6 by 12, which is equal to minus 0.5. And here also 6 by L, 6 by 12, which is equal to 0.5. If we will take addition, so it will come 1. After that, here value is how much? Here A divided by L, so which is equal to 4 divided by 12. So this value is how much? 4 by 12.
0.7.
How much?
0.73.
0.33. So this is the ILD for shear force at Z which is equal to 6 meter from A. 6 meter from A. Then last diagram we will draw ILD for bending moment. First we will draw baseline here. Yes, now you tell me how we will draw this. From A to Z value will be there. After that Z to B 0, and from this B to C we have to make rigid. That's why value will come here, and we have to close this diagram. Okay, so this is the ILD for bending moment. So this is A point, this is B point, this is C point, and this is the D point. Here Z which is equal to 6 meter, this distance also 6 meter, and this distance is 4 meter. This distance is 4 meter. Here value is Z in bracket L minus Z divided by L. So which is equal to Z is nothing but 6 in bracket 12 minus 6 divided by 12. So which is equal to how much this value?
3.
3. Okay. After that, we have to calculate this value. And this value is AZ divided by L. So which is equal to A is 4 into Z is 6 divided by 12. How much? This value?
2.
2. So this is the ILD for bending moment at Z which is equal to 6 meter, Z which is equal to 6 meter from A. Okay. Please take screenshots. One example I will do for homework. In next lecture, we will see one example if overhanging is provided at two sides, left as well as right, and then we will one point is remaining. If indeterminate structure is given, how to draw influence line diagram, and then we will cover this syllabus. Okay, so please take screenshots and take one example for homework. Draw ILD for for overhanging beam, overhanging beam, overhanging beam, overhanging beam at Z which is equal to 4 meter, 4 meter from A, from A. Now I will draw figure here. So this is simply supported beam is given A point, this is B point, this distance is 3 meter, and here Z location is given. So we will call as a D point. This distance is how much? Z which is equal to 4 meter, and this remaining distance is 6 meter. So here L which is equal to 10 meter and A which is equal to 3 meter. Okay, so solve this example. Today we will stop here. One last point is remaining. We will cover in next lecture, and then our syllabus is over. Okay, so thank you for attending lecture. Thank you.